Hello everyone, welcome back to the channel. So in this video we are going to look at the problem named partition list from lead code. So this problem is based on linked list. According to the problem statement, we'll be given the head of a linked list and a value x, and we have to partition the linked list such that all the nodes less than x all the nodes with value less than x should come before the nodes with value greater than or equal to x. And also we have to preserve the original relative order of the nodes in each of the two partitions. So it means that in each of the two partitions the relative order of the nodes should be maintained, and we want that in our linked list all the nodes with value less than x should come before all the nodes with value greater than x, greater than or equal to x. So the problem statement is very simple. Let us understand the approach to solve this problem using this test case. So now let us see the approach. Our x is equals to 3 and this is the linked list given to us, and we need to maintain the relative order of the nodes in the two partitions, so we must keep this in mind. So what we will do is that we will not create an entire new linked list from scratch, but instead we are going to use the nodes of this given linked list only, and we are going to partition. So how we are going to do the partition? For that I will initialize two dummy nodes. So the first dummy node, I named it as less n. So all the nodes with value less than x will be attached to this dummy node, and I have initialized another pointer a, and I have taken second dummy node and I named it as greater n. So all the nodes with value greater than or equal to x will be attached to this dummy node, and I have initialized another pointer b also, which will point to this dummy node in the beginning. So now what we'll do is we will start traversing through the given linked list. So in the beginning the head pointer is pointing at this node with value 1. So as the value is less than x, we want this node to be a part of the first linked list. So we are what we'll do is we will do next of this node to point at this node. As the value of this node was less than x, we will attach this node to the next of this dummy node. So all the nodes with value less than x will be attached to this linked list, and all the nodes with value greater than or equal to x, we will attach those nodes to this linked list, to the second linked list. So after this we will move our head pointer to the next node, and also we are going to increment this a pointer to the next node in our first partition list. Okay, the node pointed by head pointer is now having value 4. As 4 is greater than 3, we want this node to be a part of our second linked list, which will comprise of all the nodes with value greater than or equal to x. So what we'll do is we are going to point the next of the node pointed by pointer b to this node. So it will be something like this, and then we will move our head pointer to the next node, and our b pointer will also move to the next node. So after this again we will check. So next node is having value 3. As 3 is equals to x, we want it to be a part of our second linked list. Hence what we'll do is we will do b dot next to point at this node, and as it is already pointing, so it will remain the same. Okay, and after that we are going to move our head pointer to the next node, and our b pointer also we are going to move it ahead. As this node got attached to the second list, we incremented our b pointer also. Now again, when we check this node, so as the value is less than x, it means that this should belong to the first list. So what we'll do is we are going to point the next pointer of the node pointed by a to this node. So node pointed by a should point to this node. No, it means that this link will be removed, as the next of this node is now pointing to this node. And then we are going to move our head pointer to the next node, and we are going to increment our a pointer also to the next node. So a pointer will come to this node. Again, now we are going to check this node. As the value is 5, which is greater than 3, we want this node to be a part of our second linked list. So we will do b dot next to point at this node 5. Okay. So after this, we will increment our head pointer to the next node, and b pointer will also move to the next node. So it will now point to this node. Okay. Now again, we are going to check this node. As the value is 2, which is less than x, we want this node to be a part of our first linked list. So we will do a dot next, and it should point to this node. Okay. After this, we are going to move head pointer to the next node, and a pointer will also move to the next node. Now, as head pointer has reached null, it means that there are no more nodes left. In our last step, what we are going to do is we want to attach these two linked lists such that all the nodes with value less than x should come before all the nodes with value greater than x. So for this, what we can do is to point at the beginning of the second linked list, which comprise of all the nodes greater than x. So it should be greater n dot next. The last node of the first linked list will point at the first node of the second linked list, which means that this node will point, which means the next pointer of this node will point to the first node of the second linked list. Okay. With this, all the nodes with value less than x are coming before the nodes with value greater than x or equal to x. So after 2, we are having the first node of this greater linked list, and now the next and the last thing that we need to do is we want that the node pointed by b pointer should point at null, because currently this last node of our second linked list is pointing back to this node, which is a part of our first linked list. So it means that there is a cycle in this linked list. So b dot next to point at null, then our task will be done. So this should point to null. So now this is a linear linked list with all the nodes less than x coming before all the nodes greater than or equal to x. Okay, and at the end, all we need to do is return less n dot next. So we are returning the less n dot next, which is the next node of this dummy node which we created. So linked list will be returned starting from this node. Okay, so this was a pretty simple solution to solve this problem. Now, so the time complexity of this approach is big O of n, which is the size of the given linked list, and space complexity is also constant because we use the nodes of the given linked list only. We only created 2 dummy nodes, but for our modified linked list we use the nodes of the given linked list only. We didn't created all the nodes from the scratch. Now let us see the code of this solution. So we are given the head of the linked list along with integer x. So firstly I have created this dummy node with name less n, and I have also taken a pointer p. Similarly I have created a dummy node with name great n, which will comprise of linked list with all the nodes with value greater than or equal to x, and I have taken this pointer q in order to iterate. So while our head is not equals to null, we are checking if the value is less than x. We are doing p dot next to point at this node, and we are incrementing our p to the next node. Else if the value is greater than or equal to x, we are doing q dot next to point at this node pointed by head, and then we are doing q equals to q dot next. We are incrementing our q pointer to the next node, and here we are incrementing our head to the next node. Like this, one by one we are checking each node, and we are partitioning it according to the given conditions. And at the end, once we are done with all the nodes, we are doing q dot next to point at none. So this means that the last node of our second linked list, which comprise of all the nodes with value greater than or equal to x, so the last node of that second linked list should point at none to avoid any cycle in the linked list. And here what we are doing is we are doing p dot next to point at great n dot next. P pointer is currently at the last node of our first linked list, which comprise of all the nodes with value less than x. So the last node of the first linked list should point to the first node of the greater linked list. So with this, what we mean to say is that all the nodes with value less than x should come before all the nodes with value greater than or equal to x. So after doing these two things, we just need to return the less n dot next. So we are returning less n dot next. Less n is the dummy node, so the next of our dummy node is the head of our new linked list. So this was the code, and if I submit this, as you can see, it got accepted. So this was it for this video. If you understand the approach, please consider liking the video and also subscribe to the channel for more such coding content. Thank you and have a nice day.